Hi everyone, welcome back to another Simple Planes video, and in this video, I'll show you all the progress updates for the SWL-120. And oh boy, there's a lot to talk about, so let's get started. I don't even know where to begin here. So this is what I call a test fit, where I put all the components together into one file and make it fly. This is test fit number 3, and this does fly. However, there's of course a lot to do, especially in the cockpit here. And I'm not really sure where I left off, but pretty much everything in here is brand new, aside from part of the throttles. But this overhead panel, a lot of stuff here, and this whole waypoint computer and radio computers, which I'll talk about in this video, is also brand new, and there's a bit of code. And also this is going to use a brand new autopilot, which I'm going to code in a few videos. Not this video, this video is just about the progress updates. But anyway, might as well show you those. So I guess I might as well, I'm not really sure where to start even. I'm just going to start over the base of the plane. Now, I didn't really check my last few videos, so I'm not sure what I have or haven't talked about. I'm pretty sure I talked about this landing gear, but anyway, with the new beta, I added some new landing gear to this plane. Not new landing gear, but I added the new wheel styles. I also did I'm pretty sure I talked about this, but I did a paint overhaul where I neatly organized all the paint colors and made anything I don't use be red. This tail is pretty simple as of now. It's got all the control surfaces, but there's of course going to be a few more details. And these wings, you may notice some rivets. Now these rivets are actually the label part with a bunch of full stops in a format that makes them be round. But they add so much detail for like 12 parts per wing. And I'll show you more about them very soon. These are also used in the engine, which I'm pretty sure I've talked about. And that's that part. Now for this this is where all the updates are really. I mean, there's the rest of the plane, but that's not that much. So I think I'll start with the overhead panel. Now, last time I talked about the overhead panel, I had maybe 3 of these panels. It was just the engines and APU section, and part of the electrics, with not all of this in here. And then I think maybe I had a few lights. And now I have the electrics, fuel and hydraulics panels, the pneumatics, which is pretty much pressurized air, and a bunch of lights. So starting with the electrics, I'm just going to start in order of how you'd start this plane up. Oh boy, that's going to be a thing in itself. So, electrics, you have the batteries, and then you have all these other sources. And each of these buttons is what I call a dynamic display or something. So I have this code that displays certain things if other conditions are met. For example, let's say the battery is turned on and the battery is displaying power. Then it'll display on. It'll display flat, like in this yellow text here, if the simulated battery charge was 0, or a bit less than that, a bit more. And I'm not really sure how well I'm going to explain this, but I've got somewhere in here, where is it? Ah, here it is. I have this here code, which actually calculates how charged the battery is in a way. Here you go. Not sure if you're able to see this, I'll just zoom in a bit. But the way this works is I calculate, so first of all I get each of the lights inputs, so currently this is only set to lights, but I'm going to add everything else later. So let's ignore all this. Let's say we have a battery which has a fictional capacity of 1000. Let's just say that. And we have our lights, which in this case I'm just going to say lights. And let's say these lights, so each of these also draws different amounts of power from this fictional thing. It's like, for example, it's not really in real life units, but but they each draw different amounts of power. And also, the load is distributed between both batteries if both are on, or if only this one's on, then the full load is given. I'm not sure how much sense this is making, but I'm trying to make sense. So lights. Let's say you have these lights, and let's say they draw 5 fictional units of power. I'm going to put all this in brackets. So 1000 is a fictional unit, well basically the max charge of the battery. And I haven't really figured out charging yet, but I'm going to get there. So So some, and I should have made a video on this earlier, but my next video will probably be a video about different funky trees functions like sum, clamp01 or clamp, or any of them really, and all their uses. So that is minus sum, and sum, as I mentioned in my custom engine video, is the sum of an input over time. So sum lights times 5, and this is the sum of all of this. So really, let's say we have 2 lights. The way I do that is I'd have lights 2, so really just the second lights times anything else. And pretty much just add them together, and I actually would put brackets around that. And then this is pretty much this code here simplified to this, and that's that code. It's a little more complicated, but I try to explain it. Right, and then that's the batteries. All these other ones, they don't really have an actual code that tells the charge because they're just generators from the engines. And the engines, they're meant to draw fuel just like similar to how the batteries draw the charge. And that way I can have different fuel tanks here discharge fuel based on if the pumps are on or not. I'm not really sure how I'm going to explain this, but I've tried to. So I might as well just go to show you how this works in the level. Little side note, I am getting currently 40 FPS in this maybe 1/3 finished airplane. I'm probably going to have to remove the seats. Alright, so in here, currently everything is off, and you can see that. So the batteries, I can turn them on, and they display that on text. And then, another thing I've also managed to do is when you click, step 1, turn the electric master on. So also, you can turn on or off the backlight in a way of the text on everything. Mostly everything, I need to fix that. Mostly, like, it's still work in progress. And this is the overhead panel. There's also the center panel, so note the condition of this. Center panel on. Oh look, everything's on. And also, some of the stuff here, like these numbers, is completely gone if the backlit, what did I call it, center panel lights, I guess, is off. That's because I can't really figure out a way to get, that's because I can't figure out a way to get buttons to display different types of emission based on different conditions. I'm just going to turn all these lights on. And also, this is what's called a load meter. In real life, this would display amps, like the amount of amps all the systems are drawing from a certain device. But in simple planes, I'm just going to say out of 100%. The reason is because of the dials that I'm using, because these are actually dials, not some text. And there's also one for each battery, and note the behavior when I turn off, let's say, battery number 2. This load meter here goes down to 0, and this one goes up to basically twice its current value. The voltmeter, it goes from 6 to 5 based on the bat charge, so bat charge is at 100%, then this will be at 6 volts. This goes down to 0%, this will be at 5 volts. So it slowly goes down to 5 over the course of this discharge here. And what should happen is when any other input is on, that will charge the batteries back up. I need to work that out still. Should be pretty simple. And also the load meter goes up, of course, as I turn on more lights. Now actually, now that I think about it, a lot of these lights here are still tied to activate 8. Can't see that because I hid the display here. But it's actually tied to activate 8 still. Anyway, so is the flaps actually, they're still on normal volt visual. Without activating anything, I can still use them. Oh, and here's the rivets, by the way. There's also more if you extend the flaps down here. Same with the slats. Not really sure if I actually showed this view, but it looks pretty nice. And this is the tail. Pretty simple. I need to add more details, but basic control surfaces. And I might need to tinker with the flight characteristics of the physics wings still, but it sort of flies fine. So I'm just going to speed through most of this process. So fuel, each engine can draw fuel from different tanks. I'm not going to explain this in this video, because the video is already going to be pretty long. And the APU, now in the SWL-120, 10, my most recent highly detailed airplane that's not currently in development, to start the APU or any of the engines, you just click the master switch, aside from fuel and other stuff. So you have fuel and other conditions, master switch, and then you just hit the starter switch once. Now in this plane, you need to hold the starter switch down until, actually you can see here with this dial here, meets the 6. And that is 6 fictional units of compressed air. And there we go, it's now at 6. And also, I'm just going to turn it off again. If you release it, it will just slowly go back to where it was. And if I just turn off the overhead lights, you can see the text now appears. See, there's actually some text here. This panel here is not fully complete. There should be some more dials and stuff, but all these dials over here will be kind of useless because they have stuff like air conditioning, which it's not really in single planes. Anyway. Also, I'm not really sure if I showed this, but the way the text can be turned on or off is there's actually 2 texts with the exact same text in the exact same position. And one has the emission has 50%, the other has 0%. And of course that means one's currently in development will be hidden anyway. So then you click this one so this is the main duct pressure, I think it's called, dial. That displays the actual pressure that's available for aircraft systems. I'm thinking of making it so certain systems actually draw air from it, like reduce the current displayed duct pressure. And these are the engine start dials. I'm not going to explain all the code behind this, but pretty much you click them to start, and then I think a compressor will start up in this engine. Now, of course, in the terms of single planes function, there's like 10 engines in that one engine, which is a custom engine, each doing different things, and that's all for sound effects. And then when that engine pitch has increased to the max or whatever, then you turn on the fuel power, and then the engine will start to turn on. That's the main engine here. Then we can repeat with the other engine. And also this snaps back to start, well, I mean on. So it's a pretty detailed startup sequence, and I'm not going to try and explain it in this video. So we can start up other engine. Oh, and avionics, I forgot to talk about that. So avionics, click this, all this is back on. And this is a working waypoint system, and I will actually explain that in a separate, not in a separate video, but I have this system itself, well, not the system itself, but the selection part of it, which is all of this stuff, in a separate file, not in this plane. Why am I moving? I need to add a parking brake. And then for hydraulics, which currently doesn't actually control systems, but it should. You can have all the engine generators inputting to it. Same with... I just turn the whole plane off. I'm stupid. Okay. Right, APU back on. Engines to start. Fuel has to be off to try and start them. Engines are starting up. Start engines. There we go. And then we can turn the APU off. And there we go, the plane is, as of now, fully started up. I'm just going to take it for a quick flight. I'm just going to go back to Wright Airport, so I'm going to try and make a good takeoff. I think that was a pretty good takeoff. And there's some bugs I need to fix, like how every single display here goes weird in certain aspects of the flight. I'm not sure why that is. I'm also not sure why the buttons do it too. Some weird issue, I'm not sure why. Anyway, there's also this autopilot panel. This will come in handy when I eventually code my new autopilot, which I'll do not now. the dials work, and there's buttons hidden behind them, so instead of just being buttons like there were the original dials here, the buttons are hidden behind the dials, so it looks as if you're actually turning dials. And of course, for ones where you'd have to click the dial 180 times, you can just adjust them in 10. There we go. Now, of course, none of this works, but eventually it will. And I do have part of the displays, which I'll show later if I remember. And I'll just show you the landing. And also for the landing, you'll see the suspension needs to be a little harder, it's a little too soft. I'm not sure if you saw that, but the suspension was very soft, like it was too soft. And just to demonstrate, I'll show you what it looks like when I land pretty hard. You can see how the landing gear legs really compress. Like, I guess that could be okay. I don't know. Anyway, so I think that is it. And also, the engine reverse thrusters currently just increase the thrust output of the engine, don't have it, so they actually provide any reverse thrust yet. I need to fix that too. There's a lot of things I need to fix. Engine fire handles are also in here, and they don't do anything, but they should tell the engine to just shut off. Not that they can actually catch on fire anyway, because simulplanes. And now I'll show you that waypoint and radio system, which is another very advanced system. So this is that center panel thing here that you saw, as well as the whatever you call it thing, of which there are two on the panel. I don't know what the names of things are sometimes. Now, there are actually two different systems here. Well, ignoring the cabin lights thing, there are two different systems here: the waypoint computer and the radio system. Now, the way of inputting numbers to both systems is pretty much the same, which is code in itself. I'm just going to activate the lights. So, it's pretty much simple, really. You input some numbers, and then you click something to input it. And that was a lot of code, but I'm just going to show you the output. I'm not going to talk about the massive code behind it. That'll take many videos. So this is the same number system for the radios. And note, these two sections here are exact copies, so this computer here and this computer will display, I guess, this display here and this display here are absolutely the same. Same is for this input pad and this also. What am I even saying? Anyway, so also for radio frequencies, you also add 2 decimals to them. So in the code, it's actually just a standard number, like let's say if I input. Oh. I've just found a bug with this. I shall need to fix this bug. Never noticed that. It's where the number is capped at 200 in the code, but it's actually just 2 here. Anyway, that's a bug for me, not for you. And then what you do is you'd make sure the motor's on right, and then you can write this number here to any one of these 8 things here by clicking the appropriate button. And then if you want to, so let's say, so it's like the SWL-110 where you have the nav 1, nav 2, com 1, com 2 radios, except it's stored in the computer. And then you can choose the single active frequency from a selection of 4 each, nav and com. And when you actually want to do that, when you finish writing in your frequencies here, using this pad, then you can click here and the mode changes to read. So then these buttons, instead of writing this value to any one of these frequencies, they actually get this frequency. They highlight it in green, that's just a tiny bit of code. Then they put it up here in the active frequencies. I should probably label active frequencies. And this notepad also has some buttons, as well as just the numbers, so you can clear it. I wanted to put something else here, but I wasn't sure what to put here, so I just put two clear texts. And that's just the radio frequencies, which is going to be used for the ILS system. And the comm system doesn't actually do anything in simple planes, but it's there for realism. The waypoint system, though, oh boy, that's going to be pretty complicated. Not too complicated. So a waypoint is, I think the best ways to describe it for simple planes would be a latitude of longitude of a particular, would be the latitude and longitude of a particular point in game. For example, the coordinates for Wright Airport are what it says here. So this button here puts your current position as a waypoint in the temp values. First of all, in simple planes, there are some, well, not simple planes, but I've made it so there's a bunch of pre-programmed in waypoints, which are all of these, and I'll show a map of them soon. And then out of those, there are 6 custom waypoints, which you can set the values of yourself. Custom waypoints 1 to 6. And this is actually a temp value, so it's like custom waypoint 0, but it's not like a waypoint that you can use in the system. It's just like a temp value, last and long. So you click on, when it's in write mode and you have some stuff in here, you click on any one of these waypoints, and the last and long of up here are then written to the selected waypoint. And also, same idea for these buttons, this value is then inputted into the whatever you selected. And you can also invert it to be negative, because waypoints can be negative too, latitude and longitude coordinates. And they can also clear the text. And then when you want to read it, you then click this button that changes to read or write. And initially it will display zeros, but when you click the waypoint, then it'll display the waypoint values. So this reading here, this is not for an active waypoint. This is just so you can view the values of these 6 waypoints, in case you want to know those. I'm not sure how to get the view over here, but the selection is sort of the same. This stuff here doesn't do anything, like these letters and these buttons. It is literally 4 labels. That is it. And I'm not really sure if you can read it. You shouldn't actually have to read it. And then here, out of these 20 waypoints, you can select the one waypoint that will be active and will be used in the waypoint. So this is turning into a lecture. So the way this works, the waypoint system, after you get all your selected waypoints, is I have some other code that calculates the heading to the waypoint as well as some other parameters like the distance to the waypoint. And that heading of the waypoint can be fed into the autopilot as the target heading if some certain switches are flicked in the autopilot panel. And also, I'm sort of figuring out how this can be done, but it's definitely possible. You can have the system where you can program a flight plan up to 10 waypoints or more actually, and you program the waypoints in order of where you want to fly to, and then you click a button, and the plane will fly through all those 10 waypoints or whatever many you set for you. Now the code behind it will be very advanced. Not too advanced for me though. And I will try and make some videos explaining how that works. But first I need to develop that. So that's the system, and one last thing before I go is I'll show you that waypoint map. And here we go, so this is the waypoint map. And it has all the names of the waypoints too, as well as the coordinates. Now I just realized, well not just realized now, but I'm probably going to have to make a whole book on how to fly this plane, because there's so many features in it, and there's so many things you have to do just to get in the air to begin with. I'm also going to probably include a few, like in a way, cheat codes, not cheat codes, but like cheating buttons, where you can click a button and the plane will automatically start up for you. So if you just want to fly the thing and look at the cockpit, then you can do that. Shouldn't be too hard, just a bunch of variable rating things. So up here we have, this is pretty much Snowstone Island and Avalanche Airport. And the waypoint naming conventions are just 6-letter capital letters, sort of based on what the waypoint is and where it is. For example, this here is right app, or right approach. which is sort of like where you'd start to approach Wright Airport, which is also Wright Air, and Rysap. What's that? I guess that is sort of like Right to Skypark City approach. I was just trying to give them all different names. And then this here is the coordinates of the Wright North runway. So this is sort of a map to fly to all the major airports in the game, as well as just a few other areas. And all these waypoints are listed by name in this here flight manager computer. That's not what it's called, but I think it is in this computer. I just don't know the names of things today. Anyway, so that's the waypoint system. And there's probably something I missed. Let's check to see if I missed anything. I guess it was this thing. So pretty much this is what I call a sine wave graphing device, but the real name for any of this stuff is pretty much something I learned in school a while ago, and it allows you to graph the values of trigonometric equations, I guess. And I'll try and explain how this can be useful for us now. This can be used for autopilot, where we get a sine wave and we change it a bit so based on parameters it does things. I'm not really sure how to explain it, but all I know is that it will help us with the autopilot. It's like I know how it works in my head, but I can't explain it. I'm trying to make a video on it. Anyway, so that's that. I have a lot of stuff to work on. And in the next video, I'm not sure what I'll make. I hope you enjoyed. Make sure to like, comment, and subscribe, and I'll see you in the next video. Bye!